Welcome to our 2025 webinar series today. Today's topic, the linear progression of Beckhoff XTS technology. I'm Jeff Johnson. I'm the Mechatronics Product Manager with Beckhoff in the US, and I'll be co-presenting today with one of our customers, Tom Brooker from Bartell. So the XTS or Extended Transport System will give you a lot of benefits and advantages in innovating your machine designs and processes as it has evolved over the years. So this timeline here shows the progression of the Beckhoff XTS technology. Back in the early 2000s, we developed a concept for a linear transport system working with one of our customers, Bosch Packaging, which is now called Senegon. And we showed it in 2008 at the SPS show in Germany. So from that initial, think of that as it was more of a concept design. Could this concept work? Is it feasible for the industry? Well, the concept was well received at the show and generated a lot of excitement. So we went back, we took everything that we learned from that, and then in 2012 we released what is now the production version called XTS. In 2014 we partnered with HEPCO for a more robust rail system. We also released the 45 and 22.5 degree curves. Then in 2018, we released track management. 2019, we expanded our magnet set for lighter and heavier payloads, faster machines. 2023 brought about the Hygienic XTS system. And then last year, we released no cable technology or NCT, which allows you to put actuators and sensors out on the movers with wireless power and data. And then HEPCO also expanded the line with the GFXR and strong movers for heavier payloads. This year, we're going to see 45 and 22.5 degree hygienic motor modules, along with a 10-pole magnet for the system. And HEPCO will be releasing a full aseptic stainless solution. So we're going to take a little deeper dive into each one of these, but I wanted to show the general timeline at the beginning just to give you a feel for how the XTS, while it was released over 10 years ago, we're continuing to evolve it and expand upon the product. So let's go start at the beginning. So this video here is showing the actual initial concept machine that we showed at SPS. It's feeding the product to a flow wrapper. So some of the things that we realized, with this concept, that we looked at it was, we're going to eliminate, multiple lines of servo drives, servo-driven conveyance and sensors, which will reduce the cost. We could see reduced tooling, reduced footprint, and the fact that each mover can move independently, that's a big game changer for this type of technology. Now, instead of everybody indexing at the same time doing your work indexing, each mover can move independently. So this is a key feature to it. We first thought from a use case, we'd see, common lengths 3 to 4 meters. In reality, our largest system is over 160 meters long today. Light payloads, 20 to 30 grams, which was, for the high-speed packaging, that was the initial focus, but now we can go all the way up to 40 kilograms with some of the new heavy-duty movers. With the ability of the independent motion, we also have the ability to do, create multiple products using, collating multiple products together. The infinitely variable product pitch is another key factor, and software changeovers. So, like I said, in 2012, we released XTS, and we're off and running. So just a quick overview of what is XTS. So with XTS, we combine the benefits of linear and rotary. So we sort of flip-flopped it. So the motor modules are the power and electronics, feedback, everything. And then the magnets, instead of being permanently mounted to the machine, are on our passive movers. So the movers can move freely around the track. They can move independently. You can move them in groups. We can gear them. We can cam them. We can take 2 movers together to clamp products. So it gives you a lot of flexibility in your motion. Now, it's not a standard, independent where like you index, do your work, index, do your work. You can have constant motion going around the system. Each mover can, accelerate, start, stop at a position. Like I said, we can gear them, we can cam it. So any of the typical motion that you're doing with a standard rotary motor, you can do with XTS. You get the rotary because we have the closed loop track. It just continuously goes around. Like I said, one of the big benefits is of the decoupled motion. So on these 2 videos here, what you can see is it's the same machine, but it's creating either stacks of cookies or sleeves of cookies. So on the fly changeover, you can switch from creating stacks to sleeves. You could change the sleeve length. So instead of putting 10 cookies in a sleeve, Halloween's coming up, but they want to do little snack packs, you could also do 2 cookies for it. So nice thing here is no large mechanical changeovers. By just a touch of a button on your HMI, you can switch from stack mode to sleeve mode. It's a very modular system. So when you look at it, it's really 5 components. So we have our industrial PC running our TwinCat software. With TwinCat, we do all of our configuration, programming, and everything in TwinCat. We have our industrial network, which is called EtherCat, which connects to the motor modules. Then the motor modules connect together to create the track shape. And then you have a guide rail and a mover. So it's really just, it's a very clean system mechanically. It's very clean from a component standpoint. We have lots of different types of motor modules. We have different lengths from straights from 233, 249, 250 millimeter lengths. And then we have 45-degree curves, plus and minus 22.5-degree curves, and our nice little clothoid, which gives us a really small footprint. So that enables all these different track layouts. So think of just a standard oval, you see a lot of them, but we can do L shapes, we can do Z shapes, pretty much any layout here that we can configure, even rings. So you can start creating smaller, replacing standard rotary indexers with it. Another key benefit is, it can shorten your time to market with innovative concepts. So an example here, this is a good one with the decoupled motion. So you take a standard machine where we've got 5 stations. We're going to index every 4.5 seconds, so we get 1 part every 4.5 seconds. Our slowest process is 4 seconds, so that's 1 part every 4.5 seconds, or 800 per hour. Now with XTS, you take the same concept. We can do a 4 up on the slow process. We can create queues before and after of 4 movers. We can also, like on the first station is 1 second, we can make that a 2-up station. So now by doing this, we've made the machine a little bit longer, but we've went from 1 part every 4.5 seconds to 4 parts every up to 3,200 parts per hour. So this is where you can get really innovative with your concepts. Now you can do a lot of things that you couldn't do with the standard fixed pitch indexing type system. From a performance standpoint, up to 4 meters per second, or 157 inches per second. We can do up to 10G acceleration. Payloads of up to 44 pounds or 20 kilograms per mover. 10 micrometer repeatability, which is about 4/10,000ths of an inch. Down to 50 millimeter or 2-inch center-to-center spacing. And then another key feature is we have a mover 1 identification. So the system, from a positioning standpoint, is absolute all the way around the track. So there's 0 position. And then on power up, we can detect our mover 1 and then assign the movers from there. That way, on power up, you know exactly where every single mover is on the system. One question we get asked is, how hard is the system to configure in that? So we've got a little short video here showing our simulation builder, so you can actually build the track ahead of time. You can build up your system. You can add your stations, add your movers. And then as you're running, we've got pre-programmed software. So on our GitHub, you can download sample code. So you can actually create and simulate this on your laptop for your whole system. If you want to add an HMI using our HMI package, you just point at the XTS configuration. It actually draws the shape of the track. In this case, it's an oval, but if it was one of the more complex L shapes, it would draw that for you. You can add things, diagnostic stuff into your HMI. You could add your movers so you can fully animate everything. So this is showing a simulation of a large L-shaped track, so you can sort of look for bottlenecks in the system. So with all this great technology, can this deliver innovation to your machine? So what to look for? So some of our typical industries, we're pretty much in any industry, but a lot of the key ones are packaging, assembly, interlogistics, food and beverage, lab automation, and pharma. When you look at it from a mechanical standpoint, what mechanics can be replaced with a linear transport system like this would be flight pins, star wheels, in-feed augers, belt-to-belt transfers for product spacing, buffering systems so we can provide more of a smooth product flow, sequential steps, complicated sequential steps. You see a lot of that in the assembly industry, assembly lines, and even high-speed diverting. So we've got a short little video here showing some of the different machine functions. So we can do like bottle filling, you can have multiple up stations. A pharma application here, so we're actually doing filling, capping on it. And you can see there's a lot of varying stations. So there's 1 up stations, 2 up stations. Case packing and cartoning is another big use for it. The nice thing is it gives you the flexibility. So as the size of the carton grows, the movers just move closer or farther apart to do it. In this example there, we were actually forming the cartons, filling the cartons, and forming the carton at the end. In pharma and med tech, we can do lots of handling, especially with the hygienic systems. This video here is transferring vials into like a freezer, and that machine actually ran backwards. When they empty it, they actually run it in reverse. Said food packaging, again, feeding a lot of products to like flow wrappers. You can create mechanical cams to rotate product on the fly. This little video is showing how you can use 2 movers to clamp a product. So when we first released XTS, we had the Beckhoff rail system. So here you can see the rail sits on top, is mounted to the top of the motor modules, and then the movers have plastic rollers and follow on that guide rail. Lighter payloads, about 1.5 pounds. Roller life with our new spring-loaded movers, we can get a little over 18,000 miles or 3,000 kilometers of service life. And depending upon your performance, we can do heavier loads with the rail system. But then in 2014, we partnered with HEPCO because we were seeing applications that wanted even heavier payloads. So with the HEPCO, we're utilizing their V-guided V-guided rail system, which mounts parallel to the track. And then the movers, there's 3 roller movers for the 180-degree curves. And then when you get to the 45 and 22.5, then we have 4 roller movers for even heavier payloads. We expanded our magnet set. So the original magnet was the 5-pole, which gave you 100 newtons of peak and 30 newtons of continuous force. And then we expanded it 4, 7, and 10. With the 10, we get all the way up to 210 newtons per mover and a continuous force of 75 newtons. You can also use multiple movers together to carry heavier payloads. So what are some of the advantages of with having this range of magnets? We can take a look at a few applications. This is our agile mover. So the agile mover, we took as much weight out of the mover we can, so very light payloads up to about half a pound payload, but very high speed. So the mover in this video is actually stopping in the lower left-hand corner there, and we're accelerating up to 4 meters per second in less than the width of the mover. So you can start thinking of 800,000, 1,200 parts per minute with this type of a mover. For heavier payloads, then we have what we call the high drive mover. So it's a heavier 4-bearing mover with 40-millimeter bearings. And then you can also do a gantry style system for the high drive plus, where we gang 2 movers together for even like a larger payload. So you can have like a very heavy cantilevered payload in this type of an example here. For the assembly industry, one of the ask has been for press forces. So a standard HEPCO mover can do about 100 Newton press force, but we have a lot of customers, they wanted to do heavier press forces. So up until today, they would then support that load with mechanically to do the press force. What we're showing here is a test with our new GFX strong mover. So you can see in the design, it's a very strong I-beam, and the press force is designed so that it goes, the bearings support it. So with this, till you get to about 200 newtons of press force, there's no deflection of the mover, and the test is continue all the way up to about 2,800 newtons or 2.8 kilonewtons of force. So as we get above that 200 newton, we can see few little micron of deflection of the mover, but it's linear, so it's actually predictable. So now with this mover here, it's going to allow you to do even heavier press forces and simplify your tooling. You won't have to do mechanically support the tooling for a heavy press force. Another innovation was GFX-R. So here you can see this mover here, it's got actually 6 bearings. So the GFX-R for heavier payloads all the way up to like 40 kilograms per mover. Now we could go to the 6-bearing mover. But with the 6 bearings, we couldn't get it to, you can't get it around a curve. So then we're utilizing our track management to shift the movers from one track to the other. And besides using track management with this GFXR here, we've got a lot of different examples. So let's go take a look at some of the other uses. So in this animation here, we're showing how we can now shift movers from one track to the other. Advantages here, now you can have parallel processes. You could stack processes on the machine so that you could go to subloops to make your footprint smaller. So instead of having a big long linear system, you could have multiple levels of processes. While the 180-degree curve is, it's a very small footprint, you could use track management to make an even smaller loop if needed. If you want to introduce more parts into a system, so in this case here, we're bringing different set of tooling in and then shifting the old set of tooling out. You can also shift tooling out into, it'd be like a manual rework station or a manual inspection station. Here's an example of one of our customers' machines. So in this case here, they've got the larger, oval at the bottom, and then there are different stations for doing, inputting and outputting, workstation control for their process. But they use track management to shift movers up to the higher up. It's a manual rework station, so it's not a complete loop. It's sort of an open-ended loop with the switches. With that, what we'll do is we've got just a little video showing it. So here from the bottom track, we can transfer movers up to the manual station up on top. Then they'll come around, they'll go into the manual station for the operator, so the operator can come in and inspect things, maybe manually rework whatever they need to do. And then they can send the movers back off to rejoin the product stream. Then here you can see the movers coming back down into to get back into the flow of the product. So for more demanding applications, especially in the food and beverage and pharmaceutical, we released a Hygienic version in 2023. So this video here is actually showing our tests. So we went through several iterations of beta testing with customers. We tried things, went back to the drawing board, and it took several iterations to get the full IP69 certification. But in this video here is showing our testing at a third-party lab. Excuse me for a second. So in the testing here, what we did is we actually took, in a 3-month period, we did accelerated cleaning cycles to simulate a year of cleaning cycles. Things that we tested for was 3% alkaline solution, 35% hydrogen peroxide, 2% calcium chloride. So we did, the full IP69K, so we'll be able to meet all the demands you would from a food and beverage and, pharmaceutical type applications. The modules, it's the same modular construction with straight motor modules, curves. The initial release was with the 180-degree motor module, as you're seeing in the video here, but then we're also this year releasing the 45 and 22.5-degree curves, and then a full aseptic solution for the system. It's a short little video clip of a customer's machine showing using the Hygienic system to feed product to a flow wrapper. So at this point, I'd like to welcome our guest speaker, Tom Brooker from Bartell. I'll let him do a little more deeper introduction to himself.
So appreciate it, Jeff. Appreciate the introduction, and appreciate the opportunity to talk to everyone this afternoon regarding Bartell, the company that I work with, as well as our partnership with Beckhoff as we integrate the XTS linear mover technology into our packaging equipment. Here at Bartell, let me get this started here. I forgot to mention, but I'm the Vice President of Engineering here at Bartell. We're in Sarasota, Florida. We are a division of Promoc, and we do packaging machinery, specifically pouching equipment and cartoning equipment, primarily for food and non-food. We've been doing it for a number of years. Um, Over the last 15 years, we've actually fielded production machinery utilizing magnetic mover technology, um, such as we're talking today about with the XTS track. And as many of you guys know, the packaging environment, so we're in food packaging, let's say, it's a very demanding environment. It's not necessarily clean. It can be dirty, it can be hot, it can be messy, and we know that puts a lot of demand on the machinery and specifically the XTS technology. So prior to utilizing the Beckhoff product, we wanted to make sure that the Beckhoff product, we want to make sure that we had it fully vetted. So what we did is talk to Beckhoff about it. Beckhoff was very accommodating. They said, "Hey, we understand that you want to see it before you buy it. So let's give you a track. We'll try it out in your R&D lab. You try it out for a while. Let us know what you think." So we received the track. So we chose to test a hygienic version, so an IP69K version of the track, which you see in the center picture there. It's very clean. It's very impressive looking track. However, as we pointed out, the testing that we did was very rigorous. We actually ran this track 24/7 for 2 months, and during that time, we introduced a number of products. So we took this pretty little track that we have here, and we made it really dirty. So we had the system. This is video from one of the tests, and I got video of a second test we did with the same system. But effectively for 2 months straight, this track ran nonstop, and we introduced various types of products that might be used in a packaging environment. Various fillers and sugars and salts and all kind of different products that can make a mess of packaging machinery. During this testing, it was really important to us that Beckhoff was extremely receptive and very supportive of our testing efforts. And in fact, we found a few things that we, from our experiences, that we suggested that Beckhoff maybe look at in the future. And much to our happiness, they actually took some of those concepts, integrated them into the design, such that from our perspective, the product that we now purchase from them is more suited to the packaging environment that we operate in daily. And that was great testament to the support and the partnership that Beckhoff provides. At the end of the 2 months of testing, we were 100% convinced that the Beckhoff track would survive in our environments, and we look forward to utilizing it. Getting back to the XTS track in general, the reason we use the XTS track in our machinery can really be boiled down to extreme flexibility. Our equipment is utilized in demanding applications. We may have customers that on the same machine want to run product that is at a convenience store or a retail outlet such as a Walmart or something, and then maybe at a club store as well. And they'd like to run all of that product through a single machine line as opposed to having multiple machine lines to support that product utilization. The XTS track provides the extreme flexibility to be able to accommodate those requests. Part and parcel of that, and Jeff touched on it earlier. I mean, we can in the same footprint, the same machine, we can run it as intermittent motion. We can run it as continuous motion. We can do both in one machine. So, for instance, if we're filling a liquid product, we may choose to index at portions of the machine where it makes sense to stop and start and maybe help us with the seals or something like that. When it comes to filling, if it's a low viscosity fluid, we may choose to run continuous during the fill process, such that we don't slosh the product out of the package. The machinery provides, the XTS provides that flexibility for us to do that. Another important feature is and Jeff also alluded to this, the fact that the machine is such that we can move the product to the individual stations. That the product doesn't have to adapt to the machine. The machine basically adapts to the product, such that a machine that might have 4 or 5 or 6 different working stations, the product, no matter what size the product is, it goes to the station that's required for the action. We don't have to worry about pitch constraints or something like that that perhaps put us in a position where we're not exactly lined up with the station. Utilizing the track technology, we stop where we need to stop, such that we're lined up with all the individual stations of the machine. The ability to optimize movements in our business, filling time is key to how much throughput you can get through a machine. The ability to desegregate these movers. So when we use movers, we'll use 1 or 2 movers to actually index product through the system, independent of other products. So we may have some products on the infeed side of the system, some on the discharge, and some in the middle being filled. The ones in the middle are effectively independent of the infeed and the discharge, such that we can move those very quickly. As Jeff noted, we can achieve very high speeds, very high accelerations, such that we get the product into the fill location as quickly as possible to maximize the time that we had to fill. And maximizing that filling time allows us to increase the effective rate of the packaging machine that we're producing. Dynamic product settling, that's something that we do. Some of the products that we may fill, like a cracker product or a chip product or something like that, when you put it into, let's say, a bag, it may not settle all the way down to the bottom of the bag very well. The product's kind of light and airy and whatnot. What we could do is we actually shake the bag side to side to help settle the product into the bottom of the bag where we need it. And that's just an inherent feature of the product. That's not an option. It's just inherently a feature of the product. Wash down design, again, in our food environment that we deal with all the time. Really, most customers now are starting to lean towards a wash down design to give them a good opportunity to ensure that they take care of any allergens or any cleanup that needs to be done to ensure their product is safe. And then, as Jeff noted earlier, the pitchless design, the ability to have pitchless designs allows us to configure the machinery to suit our application. So again, we don't necessarily have a one-size-fits-all machine. We now have a machine that can be configured to suit the application. And we basically leverage that into what we call a suite of flexible solutions. So this particular slide that I'm showing shows some of our horizontal form, fill, and seal equipment that we manufacture under our model name of MAG. We actually, in these machines, we label our machines MAG L or B or MAG R or something like that. Basically, the alphabetic numerator at the end there, designator at the end there, tells us how the machine is configured. So, for instance, a MAG L, we configure the machine in a linear fashion. So this would be perfect for an application where the process flow is 100% inline. You bring in raw material into one side of your building, you package it in the middle, and you discharge completed pallets of product on the far side of the building. So a nice linear flow. The MAG L is the perfect process, solution for that. A disadvantage of the MAG L, though, is that it tends to be longer. I mean, it's a linear machine, right? So another configuration, we use the exact same track, we just configure it a little bit different, as Jeff noted with the configurations that we can do with the track. We configure as a MAG B. So in the lower corner, we have the MAG B, which is effectively very similar to the MAG L, except instead of just doing everything on the front of the machine, we do important actions on the front and then less important actions on the back, such that we achieve a smaller footprint with no limitation in speed. Speaking of speed, we can actually create what we call a MAG D, which is a dual output, where we bring in product and run it on the back side of the track, and then additional product and run it on the front side of the track, and effectively double the output of the machine in a given footprint. The last configuration is actually unique to Beckhoff, and that is what we call our MAG R. It's a rotary ring that we utilize for the XTS track system, where instead of going in an oval, we actually go in a complete circle. That allows us to create the same. All of these, by the way, have the same output. The mag L, the B, and the R can all produce product at the exact same rate. They're just configured differently. Currently, Beckhoff is the only producer of magnetic mover technology that creates that can create a completely circular track of the size that we can employ into one of our packaging machines. So we can use the mag R for instances where space is at an absolute premium, and the customer has to have the smallest solution available for the output that's required. A real world example of this, this is something that we ran into a while back, where there's an existing machine. It's a green machine, kind of shown on the far left there. Encircled in red is kind of a purple wall, so that the machine is just a few feet away from the wall. It's an older machine. It's been in production for a number of years. It's producing product at about 100 a minute, and the customer decided it was time to replace that. So they needed a better solution. So what we looked at first was to put a mag L, and again, that's that linear machine that tends to be a little bit longer, but it's good inline process flow. Well, the problem with this layout was that it ran into the wall. There wasn't enough space in the room available. We could not physically fit what we call our mag L machine in this floor plan. So effectively, we could not provide that solution. However, we were able to quickly pivot and say, okay, well, guess what? We can configure this machine differently. We can configure it with a circular track, which is shown in the far right picture. And with going with a circular track, we're now far enough away from the wall that it's a perfect application. And we now, at the end of the day, we're able to provide the customer with a faster solution. So this runs 150 a minute instead of 100 a minute. It's obviously a new solution as opposed to the 25-year-old solution that they were currently previously employing. And it was just a win-win. But this was an example of how we utilize the flexibility of the XTS track to get the customer into the right solution, as opposed to trying to put the square peg in the round hole. So really, all of the the road that we've traveled here with Beckhoff, it kind of came to fruition at the 2024 Pack Expo in Chicago, where we debuted this rotary machine that we have. So this machine, as you can see, it's a full circular ring. It's about it's about a 1.3 meter diameter of the ring. We're utilizing these movers. This happens to be a pouch machine, so the way we utilize it is we have one carrier of the pouch is on one bag clamp and another carrier attached to a second bag clamp. So with the two bag clamps, we're actually holding the pouch and moving it through the machine. You could see previously that we were shaking the pouch a little bit at the fill. So this all came to be from the extensive testing that we did with Beckhoff. We proved that this technology was going to work in packaging. We proved via the customer application that this configuration, this round configuration, was the right application for the customer, and they were able to move forward with a successful application. And that's what I have for you today. Hopefully there'll be some questions at the end. Love to talk some more about what we've been able to provide.
I am muted. Sorry about that. So thanks again, Tom. What I was saying when I was muted was, from a Beckhoff side, we've enjoyed working with you and looking forward to working with you and your team on all these new designs and that. So it's been an exciting 2 or 3 years that we've been working together. So next feature we want to talk about will be, go in here. So one of the big asks ever, since we came out with XTS was customers always said it'd be really nice to have power and I/O out on the mover so that we can actually put actuators and sensors out there. So the next evolution was getting wireless power and data to the movers, which we released last year, and we call it NCT, which stands for No Cable Technology. So with the ability with NCT now, we can put all kinds of different sensors and basically any end-of-arm tooling out on the movers. So our initial release, we're going to have, there'll be digital inputs, digital outputs, analog inputs, and then some PWM outputs so you could drive a little DC motor with it. Or you can also use them for just standard I/O if you need to. 35 watt, up to 35 watts continuous power and 75 watts peak. So now you can start putting things on, like here we got a little vacuum generator, so we can actually use 1 or 2 movers. In this case here, we're using 2 movers to pick a product. So again, it's showing both the benefit of NCT and the ability that, you know, we can coordinate movers together. This is a little tease one here. So while you can put a DC motor out here, we are looking at adding at some point down the road servo and stepper motors, so you can actually do part alignment. But there's also other end of arm tooling out there that you can actually rotate and orient parts with. So actually with existing end of arm tooling, you could actually do that rotation orientation if you wanted. Standard grippers in this demo here, a lot of our demos, we sort of made our own grippers. However, any end of arm tooling out there that you use for a robot, you can use with NCT that runs off 24 volts. Just another example here where maybe at some point in the process you want to transfer a part from one machine to the other. Again, NCT could use to grip it. The last little video here, it's showing the NCT actually working with our X-planer, which will be an upcoming webinar. But in this case here, each mover is a little 2-axis pick-and-place robot. So we come around, we pick up the parts, go around to the other side of the track, and then we can place them on a mover in a specific pack-out information. So as you look at the ability here that we can pick parts and actually combine it with the X-planer, it just opens the door for a lot more, you know, innovative designs that you can do with the 2 systems. So again, here's some of the different grippers that we've tested. So we do have test systems in our advanced applications lab in Denver and in our main headquarters in Savage, Minnesota. And we've had a lot of customers already. We've been working with them where they'll send us tooling, we'll get it mounted up and get it running, and then we'll come up and spend a day or 2 in lab testing out, you know, will the gripper work? Can we, you know, is there enough vacuum to hold my parts and everything? So as you come through these designs, we're there to work with you just like we have with Bartell. You know, get some of your tooling and we can do some testing, and you can come and join us with the testing. We've talked a lot about the, you know, the benefits of the small footprint, and this slide shows how with the 180 250 millimeter, or, you know, 9.8 inches long, with the 180 degree curve, you end up with about a 6.8 inch radius in the curves. So that's the outside of the mover. So it gives you a very compact system from a thickness standpoint. From the bottom of the base plate to the top of the mover is about 4.6 inches. So again, you get a very compact system. While we have the ability to carry heavy payloads with the 45 degree curves and the strong mover and GFXR, some customers have been saying, well, we would like to do this within the smaller footprint. So what we've done, we work with HEPCO for a Gantry style system. So here we're this little show demo that we actually showed at Pack Expo, and with 1 mover we can carry up to about 11.5 pounds. With 2 movers on this system, we can do up to 34 pounds with the 2, with, you know, supported by the Gantry. And then if you would do a Gantry with the 45 degree curves, then you could even get up to even heavier payloads of, you know, 88 pounds, 100 pound type payloads. When we showed this at the show, one of the things was, as it was running, a couple comments from a couple customers. One was saying, well, you know, it's running, and they were surprised at how, even though we're running different payloads here, they're all running at the same speed. And he also commented on how quiet the system was. With the V-guided rail system, it's a very quiet, smooth running system. And his coworker commented, well, besides being quiet, what's the any other benefits there? Well, our answer was, when you hear mechanical noise, you hear clattering or you hear lots of mechanical noise, that means there's vibration, there's mechanical wear. So the smoother the system, the quieter the system is, the longer your maintenance cycles are going to be. So that's another good benefit with the V-guided rail technology. You can also use this gantry style system like horizontal flat here. So this is actually a hygienic system, so we can do the gantry systems with both standard and hygienic. And in this case here, this was for a pharmaceutical application. And what they need is they needed a varying product pitch, but they wanted to get smaller than the 50 or 60 millimeter center distance. So what this allows you to do is you can have tooling from the bottom track will extend up between the movers on the top side. And now that we can get down, in this case here, they got down to about a 30 millimeter center to center distance. But then again, on the same machine, they could also run larger products. So again, it gives you that flexibility of there's no mechanical changeover. It's just simply software changeover on how close we want the movers to go together. So again, a lot of flexibility. And this style gantry, like I said, it can also be done with the standard IP65 modules. We even had one customer, they actually did a triple stack to get a really fine, even a finer pitch system. Another advantage with the gantry style systems is you can have the two movers going together, and this is a Tetra Pak machine, it's a capping machine, and what they do, they actually have mechanical linkages between the movers on the two tracks. As you can see in the video, as it goes around, the movers are mechanically linked together to do capping type functions. When they utilized XTS here, this actually tripled their current production rates. So they can, this machine here will run up to 25,000 packages per hour. It reduced the overall footprint of their existing machines at a lower cost. So again, a lot of benefits: smaller footprint, lower cost, and higher throughput. Another innovation that we released last year was our EcoLine. So on systems like we were just showing, where it's an over-under type application where you're doing most of the work on one side of the track, like in Tom's case for the Mag-Al, where all the work's being done on one side of the track. On the back side, it's simply a return. So what we've done is we've designed what we call our EcoLine of XTS motor module. So it's a 500 millimeter long motor module. And then we changed the feedback. So we made it a lower cost feedback. So what that does is it's lowered the cost of it, retained most of the functionality of the standard motor module. We have to derate it a little bit. So like on the 5-pole magnet with this feedback, the derating would be 30 newtons of continuous force versus 35, and then 80 newtons peak versus 100. But again, could be used for return. So a lot of times you don't need that performance. Absolute accuracy is about 0.7 millimeters versus 0.1. So again, with the reduced feedback, but again, we're not using this for doing the actual work, but there are applications where this type of absolute positioning will meet the application, so you could do the whole system with econ modules. The other benefit is you can mix and match. So with all these different layouts, you can use the EcoLine where you need it, and you can use NCT where you need it, and standard motor modules. So for like a real world project here, this is the customer's existing machine that they did. So they had 4 stations, and then the bottom was simply a return. So what we've done is we actually used the green modules in the drawing at the bottom are EcoLine modules. So the bottom return is all EcoLine, and then the buffering stations between each of the process stations are EcoLine modules. So by mixing and matching, we actually reduce the overall cost of the system by about 31%. So a good benefit to you and to your customers. Another benefit we provide is we provide fully assembled and tested systems. So when you get the XTS, you're not getting just a box of parts. You're getting a fully assembled system, as it's shown on the right here. So you lift it out, you drop it, mount it onto your machine bed, hook up your cables. So we can also supply control cabinets, and you can plug it in right away. You can start commissioning the machine. You can also, if you want to assemble it yourself, we can sell you, the individual components too. But there's a lot of benefits with selling a fully assembled system. It's a plug and play solution. It's fully tested. We simplify, we do a lot of the design work and send you the drawings to sign off and that. So it's sort of a win-win for both of us. Example here of our systems group. This was actually a large project we did for a customer where there's actually 3 XTS systems. So it's a couple oval systems and then actually a big L-shaped system. So in our facility, this is systems group is in Germany, in rural Germany, close to our headquarters. In this case, customer actually sent us the tooling. We mounted the tooling, and you can actually do the first FAT at our facility if need be. Sort of shows you the magnitude of how large some of these systems get, and they interact. So this is actually an assembly system for the medical industry. So we've covered a lot of ground in a short amount of time. Got to recap, just a few of the key benefits. Again, some of the benefits of XTS. Again, the one I keep going back to is the individually controlled movers. That is such a big feature. It's when you design around it, that's what gives you the reduced footprints, higher producing machines, and that. Simple design, it's compact design. We enable software changeovers, small footprints. Simulation is a big one. You can simulate the system to make sure that, do we have enough space? Do we have enough movers? Those type things. Fully assembled systems is a huge benefit. And then the key features, again, are, the modular 5 base components. So it's very clean mechanically, very clean from a software programming standpoint. Wide range of track layouts, the IP65 and 69K versions. We can do payloads from, point, 0.2 pounds all the way up to, 0.2 pounds all the way up to 88 pounds. The NCT gives you the wireless power and data for actuators and sensors on the movers, track management, separate tracks, and it's widely accepted. On the site here, I've got at least 3,700 systems worldwide. We're probably approaching or maybe even exceeded 4,000 systems worldwide. So it's widely accepted. So at this point, we can open up to questions. I know Matthew and Peter have been monitoring the chat, so they may have been answering some of the questions in the chat window. This video here is just a little longer version of the XTS and the X-planer working together. So as a tease, in a couple months, I will be also doing a similar webinar with the with X-planer, and our series will continue next month. I'm not sure, can't remember what the next topic is for next month, but there will be one, every month for our webinar Wednesdays. Okay, doesn't look like we've any questions either that or my coworkers have answered all of them.
Jeff, I've actually got a good one here.
Oh, okay.
The question was to Bartell. Can you elaborate on the learning curve for a customer that has no XTS experience? Does the customer have to hire engineers or other technical staff to support? And this is a great question. We get this fairly often in that there's still a lot of people that aren't 100% up to speed on XTS and linear mover technology. Pleased to report that the learning curve is made very, very simple. Beckhoff specifically, they have great support here in North America. So For instance, when we started working with them, the support was exemplary. When our customers started working with them, Beckhoff provides really good training opportunities for the customers. And the reality is, the utilization, the customer interaction with the XTS equipment is seamless. It's all behind the scenes. I mean, all of the all the crazy algorithms or whatnot that Beckhoff may have produced over the years are seamless. They're behind the scenes to the customer. The customer has a very intuitive, interactive screen to basically go in and say, I want to move, this or that. The simulation software is very easy to use. I mean, it just happened to be what pops up here. Very easy to use. And basically with the simulation software, you can do whatever you need to. And then the maintenance of the track is quite simple. And again, the support staff here in North America, I mean, they're based out of Minneapolis area. And they have a nice operation with a lot of good support. So long answer to a relatively short question, but it's actually a lot easier than you think. When you watch the technology, it looks like it's rocket science. When you utilize it, you find that it's very user friendly. And to answer specifically the question, our customers are not having to hire additional engineers or support personnel. They're just training what they have and coming away with a good experience.
Thanks, Tom. That was a good answer. I like that. Just to expound a little bit, like Tom said, the simulation, we do a lot of simulations early on. So a lot of times if you've got a concept, we can put together, in a very short period of time, a simulation of your system. And because a lot of times it's a new concept, maybe you need to sell it internally, you need to sell it up the chain internally, or you need to sell it to your customer. And by showing the simulation running, this is how the machines will be running in production, and show the difference, it really opens up a lot of eyes, and it helps you, sell this technology. I did have one question pop in. So the question was, do NCT movers lose power on the curved sections? And the answer is yes. So right now, we have NCT for the straight modules. We are on the roadmap would be NCT modules for the 45-degree curves. We don't think we're going to be able to do it on the 180-degree curves with that tight radius. There's not a lot of pickup area, because you can see there where the pickup is. It's on the smallest portion of the on the 180-degree curve. There's not a lot of surface area for both getting the wireless power and data up to it. But on the 45-degree curves, we feel that there will. But the other thing is, when you look at most end-of-arm tooling for robots, especially when you look at like grippers and those type things, they will they remember the state. So if the gripper's closed, when it loses power, it's going to stay closed. If the gripper is open, it's going to stay open, so you can hold product around the curve. And a lot of the vacuum generators, they have check valves. So as long as you don't sit in the curve forever and you've got a good seal, it'll actually, the check valve would allow you to carry the product, even holding it with a vacuum, around the curve to the next motor module with NCT, and then pick it back up. So there are things that you can do there. And like I said, we have systems to test. So if you have tooling and things, we can set it up in the lab and see if it'll work. Okay, let's think any more. Oh, another question. Just got another question popped in. The question is there integrated safety? Can safety zones be established? So currently, again, built in like STO, like you would have in the servo drive, is on a roadmap. We're currently working on it. We should see some movement on that, this coming year. So right now, what you can do is each infeed has its own power. So from a safety standpoint, when a mover moves into a section, the operator goes to open the guardrail. What you do is you would do like you do with a normal servo axis. You would stop it, disable the mover, and then we can drop the 48-volt power to that section. So the movers in all the other sections are moving, but just that little section of the machine where the operator's in, the operator can go in, work, clear the jam, whatever they need to do, and then when they close the doors back up, you reapply power, re-enable the mover, and off you go. But like I said, we do have STO as a roadmap, so it would be a new motor module design where we would actually have the built-in safety function. Every time I try saying there's no more questions, one pops in, so we'll wait for another minute here just to make sure nothing comes in. So there's a QR code here for a link for our upcoming one. Our next webinar is going to be TwinCat HMI and TwinCat updates. I would like to thank Tom for joining us today. It's been, very rewarding journey working with him and his team over the last 3 years. We've really enjoyed the journey together. I'd also like to thank Sarah and our entire marketing team for setting up the webinar, working behind the scenes. It's a lot of hard work to put one together. Matthew and Peter for answering questions. And not last, but the most important one would be, I'd like to thank all of you for joining us today, and feel free to reach out to us if you've got additional questions. If you want to take a deeper look into XTS, how could you use the technology? Those are the fun meetings. We can sit down, look at what your existing concepts are, and we can make suggestions and listen and work together. So thanks again, and have a good day.